Hello to everyone and welcome to Urbano Canalis Essential Training. My name is Rino, and during these 3 training sessions, each one lasting approximately 2 hours, I will show you how to work with Urbano Canalis. After you complete this training, you will be able to create new sewage system with Urbano, draw everything in plan and profile, analyze the network for pipe crossings and clashes, calculate flows, and run hydraulic calculation. Today, we will start from the top and we will learn the very basics of Urbano. We will talk about drawing the network in plan and profiles, setting pipes, manholes, and trenches, analyzing the network through data tables, precisely defining pipe invert elevations, labeling the elements in plan, changing visual appearance of the elements in plan, and many other things. Each session will last approximately 2 hours. We will have 1 hour and 45 minutes of live presentation, and after that we will have Q&A and I will answer all of your questions. So let's start with Urbano Canalis Essential Training. Urbano Canalis is AutoCAD based software for detailed design, analysis and hydraulic calculation of storm and sanitary sewage networks, including gravity, pressure and vacuum systems. It works on top of AutoCAD, Map 3D or Civil 3D. And if you run Urbano on top of Civil 3D, you will have some advantages, like advantage of using Civil 3D DTM surfaces, and also possibility to convert to and from Civil 3D gravity pipe networks. Okay, so let's start. Here we are in Urbano. I'm using Urbano on top of Civil 3D 2022 version. And this is Urbano user interface. We have the main workspace, we have the disk repository, we have Urbano ribbons, and also we have module selection. Here in this drawing, I have this surveying data that I use to create digital terrain model. In Urbano, you can use, like I said, if you are using Urbano on top of Civil 3D, you can use directly Civil 3D DTM surfaces. And that's the surface that I will use here. So if I switch in 3D view, we can see this is Civil 3D thin surface. But also, if you run Urbano on plain AutoCAD or Map 3D, you can also use Urbano Terraform, which is our own DTM modeler. And with this Terraform, you can create basically exactly the same surface as with Civil 3D. I will not show you how to create surface. I will just show you that the surface is here. I created it previously. And if you are interested to work with Terraform, so as you can see, when I apply this style, you can see that the triangles of DTM are basically absolutely the same as for the surface created with Civil 3D. So if you are interested in Terraform, we can send you some additional video materials, or I can quickly show you how to create surface with Terraform after this live presentation. Okay, so I will just hide the surface and I will use this Civil 3D DTM surface for designing my network. Okay, let's go back to plan view and let's turn off now these layers with this surveying data. We don't need these layers anymore. Here you have also this this surveying data. So if you want to create the DTM surface with Terraform, you can use these elements to create it, or absolutely the same with Civil 3D. Now I will turn on these 2 helping layers that I have here. It's helping layer and helping points. That will help me to create this network with Urbano. You notice that when you open basically Urbano, that everything will be empty by default and all these icons will be grayed out, and this is because you have to create a system first. So like I said, in Urbano you can create many different infrastructure system types, but of course it depends on licensing. If you have only Urbano Canalis, you will be able to create just sewage networks. And if I now start, of course, I can create a system without a template, but I prefer it and I recommend it that you always create a network with a template, because now you will see when you create a system with a template, you will receive all this, as we call them, configurations. For example, for data previews, for labelings in plan, for long sections, cross sections, team mappings, everything. So it's always better to start from something and then delete something that you don't want to use than to create blank system from nothing. That's just my opinion. Okay, when we talk about drawing the network in plan, in Urbano you can draw the network in three main ways. First way is by interactively drawing the network in plan. Second one is by conversion of AutoCAD elements such as lines, 2D or 3D polylines. And the third way is by importing. Here we have this import functions where we can import from many different outside sources or formats. For example, this can be S3 shapefiles, various SQL databases. It can be LandXML, also for it can be plain text files and stuff like that. But we will keep it simple for now, and we will create a network by interactively drawing and by converting this AutoCAD to the polyline. You also notice that many functions are also exposed on Urbano ribbons. We have one ribbon here for layout functions or plan functions, and another ribbon for the profile tools. And also we have here, this is a tools for parcels editing, but we will not talk about this in this Urbano Canalis training. So, and also you see that many of these functions, of course, all the functions are located here in the main workspace. For example, draw network elements, but also you have it here on the ribbon. So it's up to you if you want to start some function here from the main workspace or quickly from the ribbon. During this training, sometimes I will be using the workspace and sometimes I will just start it from the ribbon. It's completely the same. So let's go to first function, draw network elements. Here in this function, you can set up many options, many things. For example, we can define automatical labeling of elements. We can automatically label nodes and sections. We can automatically set pipes and manholes by choosing pipe and manhole item from catalog. Also, we can automatically set terrain elevations from selected DTM surface. And also we can automatically place invert elevation on a constant depth below terrain. To keep it simple, I will just select DTM surface. It will be Civil 3D DTM, but also you see that you can select between Civil 3D, Terraform, and plain 3D face elements created, for example, with some third software. So if you are using some third software for DTM modeling, you can have these 3D faces and just use those 3D faces. In this case, we will use Civil 3D, and we will use this Novi Vinodolski surface, as this is how this place is called in Croatia. And also we will select this option, draw additional points. You always want to have this option on. Later, I will show you what are these additional points. Basically, those are the points where your sections are crossing the triangles of DTM, and on each crossing of your pipe with the DTM triangle, you will receive additional point, additional elevation. So it's always recommended to have this turned on. And that's it. I will not set the pipes, I will not set the manhole, I will not set the invert elevation, but of course you can do it. So let's click on draw. And now to connect these helping circles, I will just use AutoCAD. I will turn off all these options, and I will use only center of a circle. And let's just click here and connect these points. So you see that it's really simple to draw a network in Urbano. You can see that how I am hovering over the DTM in this really nice tooltip. I have all the terrain elevations that are being automatically read from selected DTM surface. And also you can see that I'm basically drawing AutoCAD lines and blocks. So now when I want to end drawing, I will just click on enter or right mouse button. And here it is. we can see that these are basically AutoCAD lines and also AutoCAD blocks. But this is something that we call styling. And later on, I will show you how you can use different stylings. And you can also show this in different styles with realistic pipe and manhole dimension in 2D or in 3D. Okay, so now we basically draw one branch or one array, how we call this in Urbano. And now I will continue drawing, but now following these helping circles, I will start from here. When we talk about sewage systems in Urbano, and this is important only if you would like later to calculate flows and run hydraulic calculation with Urbano, then drawing direction is very important. So in this function here, you can also set this option. It says here drawing direction. And by default, it is set to flow direction. And that is how we draw this first array from points 1 to 17. But now I will draw in the opposite direction of the flow. Some users like to draw it from the outfall to the first node. So you can do it. But remember to switch now this option to draw it opposite of flow direction. And now when we click on draw, again by connecting these helping points, but notice how this purple arrow is now in reversed order, suggesting that we are drawing in the direction opposite of flow direction. Now I will intentionally leave out this node because I'm snapping to node number 4. And let's now continue all up to the end and connect to existing node. You see that this yellow circle is always appearing when I'm close to some node. This radius, this yellow circle, is Urbano buffer zone, which is Urbano OSNAP. So anywhere I pick inside of this yellow circle, I will be automatically snapped to that node, even without using AutoCAD OSNAP. In my opinion, this buffer is too big for me, so I will reduce it from 10 to, let's say, 5. Okay, and now we can see that this yellow circle is much smaller, and this is much better for me. So I will pick anywhere inside of this yellow circle, and you can see how this is connected. Now, to check that you connected something properly, we can select this function here, move node, and you see that I can select any Urbano node. And now you can see in this temporary graphics, these blue lines, that this is properly connected. Because if I move this here, you see that both sections are connected and they are moving by moving this node. Okay, I will bring it back here to the center of this circle. Let's now continue checking the other options here in this dialog. Now I will go again to flow direction, and I will use this really nice option, constant section length, where you can type your own constant section length, or you can choose between these default ones from the drop-down menu. I will select 30. Okay, so it will be 30 meters. And now when we click on draw, look what will happen. I just click here, and the software is automatically inserting new nodes, which can later be manholes, exactly each 30 meters. Okay, now we can continue drawing, and we see that the software is automatically placing these nodes on a constant distance of 30 meters. Now I will turn off this option again, because I would like to connect here, and as you can see, okay, it's 30, but if it's shorter than 30, I wouldn't be able to click on it. Okay, and let's now connect all other nodes here. And now I would like to connect here, but you can see that there is no yellow circle. I can connect here, I can connect here, but I cannot connect somewhere in the middle of the section. And that is because, again, if we check the options, it says here connect automatically to node. But if I would like to connect to a section, I have to switch here from node to section. And now this yellow buffer is different. I can pick anywhere inside of the yellow buffer. And now I'm connected to a section, and the software is asking me, okay, but where? And now using AutoCAD OSNAP, I will select this node here. And again, we can see that this is properly connected. We can check it again with the move node functionality, and we can see how this is properly connected. Okay, so that's it from the function for interactive drawing. And now let's also check the function for conversion of AutoCAD elements. So if I select this polyline, we can check here in AutoCAD properties that this is basically plain 2D polyline. And you can also create a 3D polylines and use the 3D elevations from 3D polyline as invert. You can also convert plain lines and stuff like that. But I will convert this to the polyline. To go to this function, again, you can go to draw, conversion of CAD elements, or I will run it here from the ribbon. And here you again see many of the options that you saw in the interactive draw dialog. And again, I will not set the pipes, I will not set the invert, I will not label the elements. I will only assign terrain heights using digital terrain model. DTM type, again, will be Civil 3D. The surface is Novi. And like I said, always draw additional points. Now, I could just select the polyline, but this is really nice option if you have many layers turned on, not like I have here, just this one polyline. Of course, I could just pick on it, but just imagine if you have many different layers and you don't want to turn them off and turn them on, you can just pick with this icon on this element. The software recognizes which layer this is, and now I can freely select the whole drawing, and the software will select only those elements on that layer. And now when we click convert, again, everything is converted from this polyline to intelligent Urbano objects containing nodes and sections. Okay, let's now turn off this. Let's turn off these helping layers now. And you can see now that I open the layer manager, we have here a lot of new layers now appearing, and this is Urbano layers. And it is important to say this is rule number 1 when you work in Urbano. Each element has to be drawn on that layer. So just remember, do not take elements and move them to some other layers. Also, do not rename these layers, because each section knows on which layer it has to be drawn. The same is with the nodes, the same is with the profiles, with everything with the labels. So do not use some custom labels, do not rename these labels, do not delete. You can delete them, but the software will again recreate them. If you move something to some different layer during some time, the software will bring them back to the original layer. So just remember not to change layers. This is something that is predefined and it should be like that. Okay, but for example, if you would like to change something about the layers, for example, I see that these nodes are really, this yellow color and this green color is not that visible on the white background. So if you want to change stuff like that, you can go here on the name of the system, you can go to edit, and here we can go to layers, and here we have Urbano Layer Manager. Here you can define colors, you can define line widths, and you can define the system name. So for this yellow color of the main nodes, I will explain what are the main and what are the plain nodes. So for the main nodes, I will use this dark blue color, and for the plain nodes, I will use this magenta color. So if you want to change this, change it from here. Don't change it from AutoCAD Layer Manager. Also, for the line width, I will select line width of 0.30 millimeters, so we can see it better. It will be thicker lines. Okay, that's it. And now, for example, if you want to rename the system, and you see the pattern how each layer is named. So name of the system, underscore what is located on that layer, underscore ID of the system. So first system is 0. So I will, let's say, call this my system. I will call it sewage Novi, like Novi Vinodolski, what is the place I'm designing this sewage for. And now I can click on recreate layer names. And now you can see that this has changed. Now, again, we have system name, what is located on the layer, and ID of the system. So these are just some of the rules that you have to know. Let's click OK. And now you can see that everything is much more visible, and it is easier to work and for me, and it's easier to see for you. Now, rule number 2, do not use AutoCAD commands to edit the system. For example, if you would like to delete something, I will select like this with AutoCAD selection, and I will just press delete on my keyboard like this. Then I will select the part of the system like this, and I will click AutoCAD command move, and I will move it, for example, here. Or I can use copy or something like that. Do not use that, because if you click on this icon here, reindex, which is basically refresh of the whole model, everything will go back where it is, because we are using AutoCAD only as a graphical interpreter of the Urbano model. So Urbano has its own model. We can treat it as some kind of internal database, which can be also extracted from this DWG file. I will show this tomorrow, but do not use AutoCAD copy, do not use AutoCAD move, do not use AutoCAD delete, do not use AutoCAD rotate, do not use AutoCAD scale, because for each of these functions, if you use this option, you will just be moving something graphically, and then the drawing, this DWG file will not be connected, it will not be in sync with the internal model, with the internal database. If you want to move node, use function for moving, or system. If you want to delete something, use the function for deleting. If you want to rotate, use the function for rotating. Everything is located here. On edit, you have edit nodes, sections, edit branches, you have move, copy, rotate elements. So everything has to be done with Urbano functions. Okay, so that is rule number 2 to know. Okay, so now we draw this system, and now I will tell you what are the main nodes and what are the plain nodes. So basically, all the first nodes of the system and last nodes of the system, and also branching nodes of the system, are called in Urbano main nodes, and you can see they are shown in different color. Everything in between, starting, ending, or branching, is called plain node. And we also have something that we call branches. So branches are everything in between two main nodes. But of course, if you want to break, additionally, if you want to break an array, something in between, and let's say I would like to make this node a main node, of course I can do it. But for example, if I would like to merge this branch with this branch, the software will not allow it, because we have a branching node here. So we started talking about Urbano topology. So maybe the best way to explain this is by using Urbano data tables. So now we will first time talk about configurations. So each function has multiple predefined configurations that you can use. You can rename, you can edit, you can copy, you can delete, whatever you want. If you want to run some configuration, just double click on it or click run. So each of these functions are always started as right mouse button and then select something. But for each configuration, of course, you can right mouse button on it and run, or just double click on it. So if I double click here on section geometry, here we can see all the data about this system. We see names, starting and ending node names, lengths, invert data, slope data, nominal diameter data. Everything is empty because we didn't assign it. So in Urbano, main topological elements are nodes and sections, not pipes and manholes. We can assign later if we want, or immediately, we can assign pipes and manholes from catalog to nodes and sections. But basically, we are drawing nodes and sections. So these are the sections, and also you can switch here from this drop-down menu to any of the other configurations. So let's switch to node geometry, and here it is. We see coordinates, terrain heights, node type, is it a main or plain node? And also you can switch to any other configuration. For example, data about the pipes, everything is empty. data about the manholes, everything is empty for now. These data tables can be run like I showed you, just double click on it. But in that case, this is a static preview. You cannot work, you cannot pick anywhere outside of the table. But if you would like to have it as a flexible data tables, you can click on this icon here. It says show data previews, and then this same data previews, these data tables will appear here. And of course you can expand the preview, and of course you can work, you can zoom in, zoom out, you can select, you can run some other functions as well, and also you can take it and you can snap it, you can toggle it to any part of the screen or even put it on your second monitor. But I like to have it here on this bottom part of the screen. Okay, let's now talk about Urbano selections. So again, it's not enough to just select with AutoCAD selection. So this is rule number 3. If you select it like this with AutoCAD selection, don't expect that here something will appear. This is because in Urbano we have our own selection options. By default, in each function you will see this yellow icon, which means select the whole system. So if you pick on it like this, you will see that the whole system is selected. You can even click here in mark. You can mark none, you can mark in plan or in profile, or mark both. I will have mark in plan. And now I will Control A on a keyboard, and you see that I have selected the entire system. This is the yellow selection option. Again, I see that this marking is in yellow color, which is not that great for this white background. So all these colors are by default meant if you are working on a dark background. But if you prefer to work on a white background like me, you will have to edit these colors. So to do this, go to this settings icon, and you can go to general settings, and many stuff can be predefined here, but the most important things are those colors. So just start typing color like this, and without too much explanation, I will just switch all the yellow colors to dark blue, because that is the color that is best seen on my white background. And these are many different colors, for example, for selections of polygons, selections of catchment areas, selections of nodes, sections, everything. So all these light colors, the cyan and yellow colors, I will replace with blue. Let's click OK. Let's now try it again. Control A, or you can just click here and select all, right mouse button, select all. And now we see that we have this temporary marking in blue. So this is the default selection of the entire system. But for example, if you would like to use CAD selection, of course, but you have to run it first from Urbano. So it's select selection option, then select elements. So if you want to use CAD selection like this, I would like to select this part, and now I have only this part here in the data table. Let's select this. Okay, it's here. Besides AutoCAD selection, we have our own Urbano selections. The most easiest ones and the most simple ones are nodes and sections. So if you want to select few sections, click, click, click. Here we have these 3 sections. Also, the same is for the nodes. Also, you have this is from node to node. So if I would like select from this node, I can go to any node in any direction. For example, like this, and now you have it from node to node. Pick, pick, and that is it from node to node. But also we have, like I said before, much more intelligent selection options, and that is selection of branches and arrays. So if I select a branch, you can see in this temporary graphics what is a branch. Like I said, everything in between 2 main nodes. And if I select a branch, I will get all the sections that belong to that one branch. Also, we have something that we call arrays, which in sewage system, this can mean channels. So this is array number 1, array number 2, array number 3, array number 5. 1, 2, 3, 4. But if you want to edit this topology, you can. For example, when you draw something, array by default will be from where you started drawing to where you ended drawing. So that's why this is one array and this is the second array. And you can see that it's go beyond the branching of the system. So that is the difference between branch and array. Array can be larger, bigger than a branch. And now if I want to merge it, and of course you can do it, we go to function for editing, editing of the branches, editing of the arrays. I will run editing of the arrays, and you have it here also. So edit of the branches, you have function for merge, break, reverse, rename, delete, and also for the arrays, here it is the same, merge, break, reverse, rename, delete. Okay, I will use the function for merging, and I will use selection from node to node. So let's go from this node to this node. I can automatically give this new area a new name. So I will call it A1. Let's click apply. And now when I go to selection of the arrays, you can see this is one array and it is called A1. If I select now this array, like I said, I can get all the sections, or I can switch to this special preview, which is called channels, but like I said, channels or arrays. We do not mean open channels, but just some arbitrary sequence of elements that is something that we call arrays or channels in Urbano. So you can see this is one. We can select the other one. So 1, 2, 3, and we can see now the group total data for the entire channel. So this is A1, this is second one, this is the third one. And you can see that some of the cells here in this data preview, some of them are gray, you cannot edit those, but some are white, which means that these data previews can also be used for data editing or data inputting. So let's rename this one. I will call it S1, like side channel 1, and this I will call S2, like side channel 2. The same I could have done if I went here to arrays, rename or rename automatically according to some rule, but I have only 3. But if you have multiple arrays, you can rename all of them automatically as well. Okay, so let's now also check nodes and sections. First, I would like to switch here to data preview for the nodes, and you will notice that the software is giving these names of the elements a little bit randomly. It's always some prefix that you can set your own and some suffix, but this suffix, this counter, will not always start from 1. It will remember where you left off the last time. So, but that's it, because the functions for renaming are so easy and so quick to use, and you can use many different renaming patterns. So before we do this, let's also put some of the labels. So to put some labels in your drawing, we have to go to our main workspace, and here we have the labels. So I will use for the nodes this node name. Again, double click on it, select the whole system or something else. I will select whole system and click here on label or mark like this. And now here we have all the node names are here. Let's also label the sections. You can select configuration here, or you can select it again from here, from drop-down menu. I will select for the sections again, section name, and click here on mark. And here it is. We see the section name and the drawing direction. Okay, let's now rename all the nodes. So to rename nodes, again, I can use the data table by just double click on it, or I can run this function for editing of the nodes. And here we have many different options for renaming. by many different standards. You can rename them interactively, automatically. You can rename them by arrays. This is the option I like to use. So you can select the whole system. Sorry, not this. Automatically, I would like to use this one. Here is this automatically, just you select prefix, suffix, and counter, and everything will be renamed according to that prefix and counter. But this is more interesting to me. Rename by arrays or branches. So I will select the whole system, and here I can use name of the branch or of the array as prefix. It says use monkey sign. I will use monkey sign and some point as delimiter. I will click on this icon to set these parameters. Like this, we can see now this is the prefix. And now when I click apply, each node name, you can see how everything is dynamic in Urbano. Everything automatically updates, the labels, the model, the data tables, everything. And now we see A11, A12, 3, 4, 5. This will be S11, S12, S13, and so on. This is the option I like to use. Also, I like to use this option, rename by distance, where you can select again the whole system. You can give it a prefix or suffix. For example, let's give it a prefix MH, like manhole. I will turn off these leading zeros. And now when I click apply, the software is basically searching for the node that is farthest away from the outfall, which in this case is this node, and it gives the first node name. So this is manhole number 1, 2, 3, 4, 5, until it reaches the branching of the system. So this is 16, and this is not 17. Now the software is searching for the second node that is farthest away from the outfall. And this is MH17. And again, it's repeating the procedure. Now this will be manhole 32, 33, and again, all up to the last node. So many different options for renaming. I will just show you some of them. If you need something more specific, you can ask and I can show you, or maybe you will have to use the interactive options if it's something really specific. But I think that with the options for renaming, basically you can achieve anything you would like to see. Let's also do this for the sections. So I will close this dialog. If this permanent, not permanent, but temporary graphics remains, and if it bothers you, you can just type regen from AutoCAD, or you can click here on this broom. This broom is cleaning of the temporary graphics. The same icon is here. So clear temporary graphics. Okay, let's now go to function for editing of the sections. And again, you have many different renaming options. For example, you can use automatic rename, which I will use here. You can select the whole system, or if you want to have some order, then you have to select it in the order that you would like to have it. So for example, let's select this one, and this one. Now it will be sorted, and it will go from here. You can use many different patterns. Here you can click on this question mark, and you can see different patterns that you can use. For example, counter, starting node name, ending node name, again, branch or array name, and stuff like that. So I will use just prefix S like this. I can click on apply, and now everything will be renamed like that. Or something that I like to use is that each section is called starting node to ending node. This you can do by typing, as we saw here in this patterns. So monkey 3 to monkey 4. Okay, monkey 3 to monkey 4, like this. Here you can see the preview of the new name. It will be from manhole 1 to manhole 2. Let's click apply, and that is it. Okay, so we renamed nodes and sections. Let's now go to something else, and that is drawing of the profiles. So in Urbano, drawing of the profiles is really easy, really simple. So basically, like everything in Urbano, just go to your workspace, select a configuration with which you would like to draw the profiles. Again, if you create a system with the templates, you can use some of these predefined templates with the scale. Of course, you can use scale in millimeters. In that case, the lengths of the sections in profile will be 1-to-1 with your plan. Or I would like to use this smaller scale, 1000 to 100 in centimeters, where the lengths of the sections in profile will be 10 times smaller, just to have smaller profiles, but it's up to you. You can use any scale and basically everything can be changed to look completely different. So double click on it, and now you can draw for the entire system. No matter how large the system is, you can just select it like this, and you can draw automatically all the profiles according to branch or array topology. I will draw it according to arrays. For these 3 arrays, we can set them in some specific order. So I will put them all in one column in 3 rows. And I will define row and column spacing to be 10. And also, I don't like to have maximum frame dimension for each profile because each profile is different. I will use frame dimension. And now when we click on draw, the software is asking for insertion point. Let's put it here, and that's it. All the profiles are drawn with just one click of a mouse. And now if I pick on this green polyline, now we can see what are those additional points that I showed you. When we click draw additional points, these points are basically calculated. So everywhere where the section is crossing the DTM triangle, the software also took this elevation on that position. So we get this much more detailed terrain line, which is really, really important, especially afterwards if we would like to calculate the excavation volumes. So this is the automatic way how to draw profiles, but also we have interactive way, again, by using from node to node. So let's go from this node, and again, I can go from each node, from any node to any node in any direction. I will go to this node here. You can see that in Urbano, we have this temporary marking. So you can see that how some elements are temporarily marked with selection in plan. They are also marked in profile. This is also a feature that can be turned off. But let's keep it like this for now. So I will draw one profile like this. Let's put it here. And also let's draw one profile like this, from this node to this node, like this. And let's click on draw. If you don't like this simultaneous marking of plan and profile, again, you can go here to settings, general settings, and you can search here for mark. And this is the option, mark all displayed entities. I will turn it off. Okay. And now you will see that how I am selecting something in plan, only plan will be selected, not the plan and profile. So this is the option you can turn on or off. By default is turned on. Okay, so our profiles are now drawn. Let's check them. And like I said, everything, this is default configuration. Tomorrow, I will show you how you can edit this configuration, and I will show you some of different configurations from different countries, from different companies, different standards and stuff like that in different languages. So basically everything can be translated by the user. You can set all these colors, all this data. You can basically change all the graphical and numerical, this tabular part of the profiles. Okay, we see that we have terrain elevations, but we do not have invert elevations defined yet. So let's do this. To set invert elevations, again, we can use our data tables. So let's again show data preview. We can go to section geometry, I can select one really nice selection option is also selection of the profile. So you can select any profile like this, and you will get all the sections belonging to that profile. For example, if you select this profile, and here you have these options for marking. For example, you can, mark in profile, and now you can go section by section and check everything. Or I can mark in plan, or I can also zoom to plan. And now, again, I can go one by one and check and preview everything simultaneously in plan and in this data table. Also, I can zoom in, zoom out like this, or I can split my screen so I can simultaneously see plan and profile if the system is much bigger. I will turn off zoom and I will say mark both. And now you can see for each section where we have it in plan and in which profiles. So now you see that this section is appearing in multiple profiles. I like to have this as marking plan only. And like I said, if you want to clean this temporary graphic, just click on a broom. Okay, so let's now define invert elevations. Again, you can define it through data table by just start typing numerical values here in the data table. You can also import it, for example, from some external file and stuff like that. But it's really the best way to draw it directly in the profiles or to assign it on a constant depth below terrain. Of course, you remember that when we draw something or when we converted something from CAD elements, we could automatically define this invert position on a constant depth below terrain, but I didn't. I wanted to show you the whole workflow. But let's now assign it on a constant depth below terrain. We go to function for input data, invert elevation, and here we will switch to option constant depth below the terrain. And here we will say that the depth below the terrain of invert is set to bottom inner, but if we have a pipe diameter already defined, we can say not invert, but let's say place top outer point of the pipe crown, to be on a constant depth below terrain. So this is also an option, but because we didn't set the pipes before, I will say that my invert, my bottom inner, is on a constant depth below terrain of, let's say, 1.5 meter. Selection, again, whole system or something else. Let's select the whole system. Let's click save. This is maybe the option much more suitable for water systems, but also it can be a good start, a very good start for sewage systems. So now you can see the whole data table is automatically updated. The model is automatically updated. We see that we have invert elevations in profile. We see that we have the data for invert elevation and invert depth. So everything is completely automatic and dynamic. Also, we didn't put this data yet in the labels, but if we did, also the labels would automatically update as well. So now that we have more data, let's switch label configuration. So let's go here to sections, and I will use this length and direction. Double click, select the whole system, apply, and now we see that for the sections we have length and direction. We don't need to have the names because we name the sections to be from starting to ending nodes. And also you see that you can put some of these configurations as default. So what does that mean? For example, if I set with the right mouse button this configuration to be default, and also for the nodes, I will say this name, terrain, and invert is set to default, you can run these functions quickly. So you do not have to double click on it, select selection option, and then click on that Thunderbolt icon for marking. You can just go here to the ribbon, labels, and notice now node labels. I will just click here on the nodes, and the configuration that is marked as a default will automatically be applied to the whole system. So let's click on it. And now you can see that you can even run it much more quickly from the ribbon. Okay, so that's it. We see that we have terrain elevations and invert elevations. We set the invert elevation to be on a constant depth below terrain. So we have only one invert elevation, but if we edit the inverts or if we add some drop manhole, we will have multiple invert elevation in each node. Okay, so let's now edit these invert elevations, because you see that on some places, especially here, we have some negative slopes. So if we want to check that, for example, let's select this profile, let's sort the data table by slopes, and you can see that we have some negative slopes here. Of course, you can say that this part of the system is pressure, but for now, like I said, we will keep it simple. We will have everything gravity flow. Okay, so obviously we have to edit this pipe invert that we said to be on a constant depth below terrain. Like I said, you can do it directly from the data table, but you can also use one of many functions for editing of the invert or pipe elevation in profile. So you can go here to tools for longitudinal section. You can interactively draw pipe invert. You can input and edit pipe invert, or you can edit pipe invert directly in long section. All three options can be used for drawing, for editing, or for numerical input. It's just the matter of the naming. We cannot name all three functions the same, but all three can be used for drawing and editing, and each of them has some specific feature. So let's first, so you can start it from here, or I prefer it to start it from long section ribbon. So the first function that I will start is this one, input and edit pipe invert. So I always like to define my invert on a constant depth below terrain, then edit it. But also, if you wanted to start from scratch, you can use this function as well. So you can select the whole profile like this, or, which is much more suitable, you can select from node to node in profile. So I will say from this node to this node, and now you can precisely define for starting node and for ending node of the selection. You can define depth or elevation, or you can straighten it by slope or by line. I always like to have my slopes rounded. So I will say, okay, I will have 30 per miles. You can have it in per miles, or if you go to options, you can change the slope unit. You can have percent, you can have per miles, you can have ratio 1 to n, or you can have even in degrees. I like to have this slope unit is in per mile sign. For the precision, I think 2 decimal places is enough. So 30, apply, and this is now exactly 30 per miles, as you can see here. Okay, let's go further. Let's, for example, select from this node to maybe, let's go here to this node, but I would now like to increase the depth here. Okay, we can type here, for example, depth of 2 meters. Let's click preview. Okay, this is really nice. I like 2 meters, but also I can maybe round this slope if I want, or I can keep it like this and click on apply. So that is it. Let's go further. I will go from this node to this node like this. Maybe let's increase again the slope to 7. Preview. That is really nice. Let's click apply. Let's now go further. I will go from this node to this node, and maybe now I would like to input some drop manhole. So if you want to put some drop manhole, just define different starting depth. Let's say for some reason, I would like to start here from 255. Let's say like this. Let's click preview, and by default, the software will try to change this connected invert as well. But if you click here, change connected sections invert, you can turn it off, and now you can see that the drop manhole will be inserted. Okay, maybe we can change the slope if we want, or just click apply. And that is it. Now we have here one drop manhole. You can check it. You can see that here we have different invert elevations and also different invert depths. And also we can go to plan to check our label. So if you want to automatically switch from profile to plan or opposite, you can click here on this search icon. You can select a node in plan or in profile. I will select a node in profile, and I'm automatically zoomed to that node in plan. And you will see that now we have here two invert elevations because we defined one drop manhole of 40 centimeters. Okay, let's go back to profile, and that's it. We defined our first profile, and of course you can see how everything is automatically changing, numerical parts, so we have constant slopes now, and it looks much more better than before. Okay, let's now check the other option. The other option is called draw pipe invert, but it can also be used for editing. And this is really nice option because you can also define minimum and maximum depths as some kind of helping auxiliary lines. So this is not any kind of limitation. The software will allow you to draw outside of these ranges, but it's some graphical help for you not to go too shallow or too deep. So for the minimum depth, I will say 150. And for the maximum depth, I will say, let's say 450. Okay. Also, you can set this slope step to be, again, in various units. I will use per miles, and I will say 1. So this will allow me to have only rounded slopes. It will go 1, 2, 3, 4, 5, 6. It will not allow me to have slopes of, let's say, 30.2 or something like that. So it's really nice option. So if we now click on draw and hover over any of the profiles, you can just start clicking and drawing the pipe invert anywhere. Let's solve this profile here. Again, I can start clicking anywhere and just draw the pipe invert, or you can use this icon here where you can numerically, precisely again, define invert elevation or invert depth. I like 1.5, so I will click OK. And now I can continue drawing freehandly, or I can again pick on this icon and define the depth or elevation numerically. But I have this really nice tooltip, and I have this slope step that I defined, and you can see how you can go just one by one, and you can see how the slope is behaving here in the profile. Again, I'm repeating this. I'm drawing the invert of the pipe, but if I have already set the pipe diameter, or I can even set it here in this dialog, I can set the pipes automatically, then you don't have to draw pipe invert. As it says here, reference pipe point. You can draw the crown of the pipe, so that will make more sense, but it's just the training. It's not that important for now. The function is the same. I'm just following, let's say, some kind of design process. First, we will define the invert position, then we will set the pipe diameters, because of course, pipe diameters will be the ending result of hydraulic calculation and stuff like that. Of course, you can always just move the complete pipes for some fixed distance. So let's use, for example, here slope of 22, like this. And now I can continue drawing, or maybe we see that we have really steep terrain here. Let's also input some drop manhole here. So you can pick on this icon. You can define invert elevation or depth, but we already did this. I will click here on drop manhole, and I will say that I will have a drop manhole of, let's say, 1.5 meters. Okay. And now you can see how we have now a drop manhole of 1.5. And now I will continue drawing. You see that still I have to go with really high slope, but okay, it's good enough for me because it's really steep terrain. Okay, or of course you can insert some new nodes, that is possible as well. And now I can repeat the procedure for inserting of the drop manhole. We can do it. Let's go one more time. I will say drop manhole, maybe of again 1.5 meters. Let's click OK. Let's draw it here, maybe with this slope. It's really high slope, but doesn't matter. Okay, and now maybe we can again insert one more drop manhole. Let's put it now to 1 meter. Okay, like this. And now I will go with the slope, let's say of 5, like this. Okay, I went a little bit below this helping line, but like I said, this is no limitation for you. And now you can continue drawing it. And I'm always clicking here because I would like to define it precisely. But if this is okay, you can just like this click it because you have the tooltip. All the values are in tooltip, and we can just click it like this. And when we are satisfied, click with the left mouse button, click with the right mouse button, and once more to finish the command. And you can see how we completely draw this invert with this interactive draw invert function. So these are the functions for interactive drawing. Of course, we have also the functions for automatic setting of the pipe invert according to some rules. So this is the function automatic invert calculation. You have some predefined configurations, but we will create our own. So right mouse button, let's create a new, and I will call it auto invert. Okay, you can set minimum depth below terrain, maximum depth below terrain. Let's decrease this maybe to 4.5. Minimum slope, let's decrease this to 4. A maximum slope, let's leave it to 70 per miles. Slope options, I will keep this optimum slope for minimum excavation. You can also limit the minimum and maximum value of the drop manhole. And that is it. You can also set offset from lateral inlet if you would like. And you can also automatically insert new nodes. If the software cannot compute, I like to set this option to delete existing data. So if the software cannot compute according to rules, delete the invert data because I would like to see where the software couldn't make it according to rules. Select everything, click on calculation, and before you apply it, you can click here on hide, and here it is. You can see how the software is marking everything with this temporary graphics, and we can see it says the automatic invert setting according to rules is not possible. Not possible because the rules cannot be satisfied. Okay, so we have to change something. Maybe I can go to maximum depth where it is, maximum slope, and let's increase maximum slope to 100. Okay, let's repeat it. Select everything, calculate, hide, and now it says successfully completed. So with the maximum slope of 100 and with no limitations of the drop manhole values, the software successfully calculated the pipe invert for the entire system. But let's check what will happen if I say minimum drop manhole is 20 centimeters, maximum drop manhole is 1.5 meter. Okay, let's again calculate it, and it says it's not possible. Let's hide it to check it. Okay, it is not possible. So we have to again intervene and do something if this is something that we would like to keep. Let's maybe again, we can increase the slope. Let's go to maximum slope. I will now really increase it to 150, or like I said, you can go here to insert new nodes. This is something you can do, but of course, you can go manually and insert new nodes in plan or in profile, and then of course the software will go through. But if it's okay for you that the software automatically insert the new nodes, you can select it. You can say that the minimum distance between the nodes should be 3. And now when we calculate it, okay, let's hide it. We see that calculation is now successfully completed, and this is not applied yet, but you can see how the software says, here I will insert you new nodes. In the middle of these existing sections, I need 2 new nodes to solve this according to your rules that you set. Here also 1 node, here also 1 node. So if you like to have it like this, of course you can apply it. I always prefer that I manually insert new nodes, but okay, it's up to you. So I will turn off this option. I will rather increase the slope. I will say that the maximum slope is 150. Okay, let's calculate it. It says it's still not possible. So let's check what else can we do. So for 50, minimum slope, maximum slope, slope options, drop manhole parameters. Let's maybe set this drop manhole parameter, maximum drop manhole, to be 2 meters. Calculate. Okay, now it is successfully completed. We can check it. Okay, I like it like that. You can see the differences between the new one offered by the software and the one that it was before. And now I will click apply. Let's save this configuration. You see now it is saved for later usage. And now we see that we have our complete invert calculation done by the software according to these rules. But of course, if this is not satisfying for you, but it's pretty good start, you can now go and add it with this function. For example, let's select from this node to this node, and you can straighten it again by slope. So it's a combination of automatic and manual functions. Okay, so we define now invert elevations completely. I will now save this file. So it is important to say that I said before, Urbano has its own internal model, internal database. But when you click save with AutoCAD, everything is saved inside of DWG file. All these configurations, if you change something, if you created your custom configurations, everything is stored, saved in this DWG file. So if you send your DWG file to someone, he can have all of your configurations. Okay, so let's click here. I will save it, but I will save it as, I will give it a different name, because I will also send you this these files with the video recordings. So here we will go to Urbano initial, and I will call this as Urbano Canalis working, because we will continue working on this file. Okay, but of course it's always good to save the drawing. So we now defined our invert elevations. Let's also set the pipes and manholes to these nodes and sections. All data about pipes, manholes, trenches, everything is stored inside of the catalogs. So here is the icon for Urbano catalogs. And here you have catalog of manholes, catalog of pipes, catalog of trenches, catalog of protecting pipes, catalog of top layers. So basically everything can be customized and you can create your own catalogs. Let's go first to catalog of pipes. And here you can see that you have some custom predefined catalogs that came with the software, but also you can create your own catalogs. That is something that I will show you tomorrow. You can also import, let's say, pipe catalogs from Excel, and it's really quick and easy to do it. So for the pipes, you can have circular pipes, X-shaped pipes. For example, you can check it how they look like. You can have also rectangular pipes with kinet, elliptic pipes. So many different pipe shapes. And also for each pipe, you can define all the parameters like material like nominal inner and outside diameter. You can define some custom data like manufacturer. You can basically set everything that is needed for your pipes. So this is the pipe catalog. Also, I can switch to catalog of manholes. And again, it's the same for the manholes. You can define everything about the manholes: manhole material, manhole shape. Again, we have different shapes. You have cylindrical, you have rectangular, you have centric cylindrical, eccentric cylindrical, many different shapes of the manholes. You can also have combinations of these different shapes and stuff like that. And again, just like for the pipes, you can define materials, you can define the widths and the lengths. You can set some data like manufacturer and stuff like that. And also, for example, circular or cylindrical structures, everything can be set up here. The same is for the trenches. So if you want to set the trenches to later calculate your excavation volumes, you can here in the catalog of trenches define different trenches. It can be single trench, it can be double trench with a step that looks like this. You can define all the sizes, you can define all the angles, you can define whether you would like to use sand bedding or concrete bedding. Will you use formwork or you will not use formwork? Many different stuff can be set up here in the catalogs. Also, we have catalog of upper layers, which are basically the top layers of your trench, because it is important if your pipeline is going below the, let's say, asphalt road, or if it's going beneath some macadam road or some earth material and stuff like that. And here in the catalog, you can define these top layers containing any amount of levels, any amount of layers. So I can create one top layer that contains 3 layers. Let's say first course of asphalt 5 centimeters, second course of asphalt 10 centimeters, sub base of the road 10 centimeters. And you can set these top layers to your network. And then when you are calculating or drawing cross sections, everything will be taken into account. Okay, enough about catalogs. You can check this yourself, but let's now assign and set these elements to our drawing. First of all, let's set pipes. Again, to set pipes, you go functions for setting of the pipes, or you can go to input data, pipes. Here we have all the groups and all the items from that we just shown in the catalogs. So let's select what type of the pipe we will use. I will use PEHD pipes for sewage system. And I will use maybe nominal diameter of 400. And again, just like any function in Urbano, you have your selection options. So I will use selection of branches. And I will say this branch, and this branch. Let's assign 400 millimeters. Save. Okay. You see how the profile is automatically updating. And as I showed you before, that we were defining the bottom inner, the invert of the pipe. Of course, like I said, it can also be any other point of the pipe. I decided to go with the invert elevation. Okay, so that's these 3 branches. Let's now select this one. And for this one, I will say 450. I would like to have bigger pipes. And for the last one, let's say here, let's put it to 500. Okay, and let's click save. If we check our profiles, we can see that everything is automatically updating. We see that we have material, we have the nominal diameter of each pipe group that we define here for our system. Again, we see that we have these colors, this yellow colors. So maybe if we would like to change it, I will just quickly show you how you can change or edit your profile configurations. We will talk about advanced editing tomorrow, but just to let you know how quickly and easy it is to edit these configurations. So we can go here to long sections. If you know which configuration you used, you can pick on it and you can go to edit. Or if you don't remember which one you used, you can click here on edit configuration and then just select the profile from drawing. I will say edit this configuration. And now it says to me, the software tells me this configuration sewage 1000 to 100 in centimeters. But now I have here a lot of parameters, because like I said, we are selling Urbano in more than 15 different languages, different countries, different standards, different everything. So a lot of wishes from our users. So everything to the smallest detail can be edited. So of course the function is big, but it's really simple to use because you have this interactive select option. With this, you can click anywhere in the profile and it will take you where that can be changed. For example, let's click here on the pipe and it takes you to pipe. And here we see these yellow colors. Okay, let's put it on blue so we can see it much better. Okay, let's click apply. You see everything is changing. Let's pick on this terrain line. Now we are under terrain. This is the green color. Let's switch it maybe to some brown color like this. Let's click apply. Okay, let's click maybe to this title of the profile. I will put it in blue. Apply. You don't have to click apply always. You can just click OK when you are done editing. So I will just click here on blue like this, but I will not click apply. I will continue editing. And it's not just for the graphical parts. You can click anywhere in this profile table as well. For example, let's click on this yellow line here. It's this land slope data. So this yellow, I will put it to be black. Let's click OK. Let's click apply. And now all the changes that we changed will be applied. Also, if you want to click on a header of something, you can click here on header. You can click here on header, and here you can define different name for the header. You can change color. You can basically change the height of the text, and basically you can change everything. Okay, let's click OK on this. And this is, let's say, our profile configurations that we would like to use on our project. Okay, so that's it. Let's also put some label here as well, because now we have much more data for the sections. So let's use, because now we have diameters, let's use this length, diameter, and slope label. And I will set this as default again, so that I know this is also helping that you know which one you applied. Let's go here and I will use this automatic labeling of the sections, and that's it. Now for each section you have length, you have nominal diameter, you have the slope in per miles, and you see how this labeling option is. When there is enough space for everything, everything goes in one line. Where is not enough space, everything goes in multiple lines, and where is really not enough space, it's go with this leader. But later on I will also show you how you can create also your own label configurations. Okay, we set the pipes, we set the manholes. Let's now preview the data for pipes and manholes. So let's go here to data previews for the pipes. Let's double click on it. And here it is. Now we have, you remember before everything was empty, but now we defined pipes from pipe catalog, and everything is automatically populated. Everything is read from the catalog. So we just set one function, one pipe, and this is the data from catalog. So you have materials, nominal diameter, inner, outer diameter, wall thickness, roughness, pipe volume, everything is here. And of course you can edit it, you can add your own data, you can remove some data, you can give it a custom names and stuff like that. Each data table can be sorted. You can select it by clicking Control A, or you can click on it and click Select All. You can copy it, You can go to Excel, Word, or any other Microsoft application. And here I will just click on Control V or paste. And here it is. We have one really nice preview. I will just change the column width here to, let's put 15. Okay. And now here it is, one really nice report for all of your pipes in your drawing. Let's do the same now for the manholes. I will switch to a manhole, but I didn't set manholes yet. Let's do this first. Okay, let's go to function for inputting data, manholes, or you can start it from the ribbon, manholes, and it's pretty much the same as for the pipes. Just select manhole group and the manhole that you would like to use. Let's, for example, use this rectangular simple manholes, this 1200 millimeters. Okay, again, you have your selection options. Let's select, I will select these two top branches like this. You can additionally set cover height above the terrain or manhole depth below the pipe. You can define manhole bedding thickness. I will decrease it to 20 centimeters. And this is really important function. You can define that the depth of the bottom of the manhole, you can set it as absolute elevation, or you can say that the depth, the bottom of the manhole is in relation to pipe, which is really nice option. You can say that it is in relation to inside edge of the pipe or outside edge of the pipe. I like to use like this, inside edge of the pipe. Let's, so I selected it already, and let's click save. Okay, let's go to our profiles. And now you can see that, like I said, so bottom of the manhole is 0 distance from the bottom inside edge of the pipe. I can also put it to be outside edge of the pipe. For example, let's just click save. And now you will see now the bottom of the manhole will be here, outside of the pipe. Or you can say, okay, but with some manhole depth below pipe is 20 centimeters from the inside edge. Let's click save. And now you will also have this sump depth. So it's many different options that you can set. I like to have it like this, inside edge of the pipe, 0, and click save. The thing is that if you set this to be absolute elevation, and then, for example, for some reason, you go to function for editing of the pipe invert, I will do it like this. For example, let's select that I would like to, for some reason, I will change this to be like this. Okay, let's click apply. You see that the manhole bottom is following the bottom of the pipe because we said that this is fixed. But if I said that the bottom is on an absolute elevation, then of course the bottom of the manhole would remain here and the pipe would be below the manhole. So I recommend using these options. Okay, let's bring this back here to 1.5. Let's preview it. Let's apply it like this. Okay, so that is setting of the manholes. Let's also set the manholes for other parts of the system. Let's again go to setting of the manholes. Now I will use, for example, for this part, let's use some circular manhole. Let's, for example, use circular simple manhole. This is basically cylindrical structure of 1200 millimeters. Let's click save. That is done. And for this last two branches, I will use this circular manhole with circular open. I will use this diameter of 1500 and top of the manhole smaller of 700. Okay, let's click save. And now you will see that all the manholes are set. You can also check it here in the profile. And also we will later also see it in the plan when we apply different plan style. Okay, so now that we set the manholes, let's also check them in our data table. So I will go here to data table for the manholes, double click on it. You can sort it, you can select it, you can copy it, you can go to Excel, you can paste it. And again, I will just increase column widths. And here it is. Now for each manhole, you have material, cover elevation, bottom elevation, manhole width, manhole depth, bottom thickness, bedding thickness, manhole volume. Everything is here in this really nice Excel report. Also, if you would like to have AutoCAD table, this is also something you can do. For example, you can select parts of the system, or you can select the entire system like I will do here. And again, I will select everything, and I will click here on this icon which says Draw AutoCAD Table, and you can select AutoCAD Standard or Legend. I will use Legend, and you can place the position of this AutoCAD table. Okay, let's repeat it for the manholes. Let's repeat it for the manholes. Okay, again, I will use Legend style, and let's put it here. Let's click close. And now you have two AutoCAD tables. So you can see this is AutoCAD table, and everything is here. So you can also do these kinds of reporting directly here in Urbano. Okay, so also what I showed you before was the catalog of trenches. So let's input trenches now as well. Let's go to input data. Let's go to trenches. Okay, it's here. And now again, just like for the pipes and the manholes, you can select the configuration from you can select the trench group and trench from the catalog. So we will use, for example, this. So you can create in catalog trenches with fixed width, or you can use this where the width of the trench is automatically calculated according to German DIN standard. So if you are accustomed to use with basically European standards, this DIN norm, then you can use this where the width of the trench is calculated, or if you have some of your standards, you can create trenches of specific widths. I will use this where B is calculated independence of the pipe diameter. So this is really a nice option. Again, I will use angle of the trench to be 90, and I will set this type of the trench to be here on these parts of the system. Of course, the more realistic would be that I define one type of trench for the whole system, but just for the purposes of showing everything, I will intentionally use different trench types. Okay, let's click save. And now you will see again that the profile's automatically updated. You have this trench bedding automatically appearing here in the profile hatched. And also here in the data table, now we have this data that automatically updated, trench bottom depth and trench bottom elevation appearing as well here. Okay, let's define other trenches. Now for this branch, I will use the same trench, but with the angle of 80. Let's click save. And for the remaining two branches, I will use this double trench, again with sand bedding. You can also change to use concrete bedding, or you can also use with the formwork if you have the angle of 90 and stuff like that. But I will use this double trench, again, angle of 80. And let's select this and this, and just click on save. Okay, all the trenches are now defined, but also let's set the top layers of the trenches. I showed you where we can define them in catalogs. So let's go to input data. Let's go to upper layers or top layers. And here we have, if you remember, asphalt and this earth material that we call humus. So I will select asphalt. I will select the entire system and I will say save. Again, the profiles are automatically updating and we see this 12 centimeters of the asphalt, first layer of 5 centimeters, second layer of 7 centimeters. And like I said, you can have any amount of these layers. Okay, but this function for setting the upper layers is characteristic in Urbano because it doesn't have to go from node to node. It can also go from station to station. So now I will go from this point here, where I'm outside of the road, as you can see, to this point here, where I'm also outside of the road, and I will say here, overwrite the old layer with new, and I will use here earth material of 20 centimeters. Let's click save. This is important because now if we go here to our profiles, here we can see that we have a different top layer. And of course, when we excavate this, the price is not the same. This material maybe you have to deposit on some other location. This material cannot be used for backfill and stuff like that. So now when everything is set, let's also draw cross sections. So to draw cross sections in Urbano, it's again extremely easy. Just select your cross-section configuration, and I'm repeating, everything can be changed and set inside of these configurations, from scale, from colors to this dimension style. I will switch here from standard to Urbano dimension style. You can use different hatches, hatch patterns, scales, everything. You can define which data will be here. Okay, and now when you want to draw cross sections, just select the configuration, double click on it. You can do it automatically according to branches and arrays in some nodes or every n meters of the system. I like this option. Let's say I will use every 25 meters of, let's say, this array here. Okay, in total, this is 30 cross sections. I will define row spacing and column spacing to be 10. And now when I click on draw, let's place it here. It's really quick, really easy to get all these cross sections. Everything is hatched, everything is dimensioned, all the data is here, and everything is defined here in this cross section configuration. And also we see this type of the trench with the step if you want to use this type of trenches. Besides that, you can also use interactive option and select some stations in plan or in profile and draw the cross sections on that locations. So let's select few of them. I will select maybe one on each section. Of course, you can also so let's click on draw. You can also put some kind of cross section label in plan so that you know that that cross section name is for that place in plan or in profile. I will not use this, but just to let you know, you can put the label where the cross section is, both in plan and in the profile as well. Let's click on draw. Okay, I didn't, it's now 37, but you can delete it like this and then start from blank. So I will just select few of them like this. Now it's 6. Let's click on draw, and again I will place it here. Now you can see that the trench depth here is really high because we are in this steep parts of the terrain. And also let's do it again for this part. Again, let's select few stations here, and also I will select few stations here where we defined again, I didn't click here on the X button, so I will repeat it. So 1, 2, 3, and maybe here also 1, 2, 3, like this. Let's click on draw, and we can place this here. And now we can see that we have different top layer. We have some grass and earth material here, or whatever you would like to call it. Okay, so now that everything is set, let's also do excavation report. So for the excavation report, you can also create different configurations, and inside of those configurations, you can set up everything. You can define whether you would like to have Excel file or text file. You can define depth excavation zones. This is really important because it's not the same if you are digging the trench up to 2 meters or to 4 meters or to 6 meters. So you can have all this in your report, and also you can define which data you would like to add in your report. For example, concrete bedding volume, we don't have it, so I will remove it. And also maybe what else we don't have here, we didn't use formwork area and formwork volume, so I will not use it. I will click OK, and I will click OK. Now this configuration is saved. Double click on it, select the whole system. You can group it by branches or arrays. I will group it by arrays, and just click save, and Excel report will be created automatically with really detailed, really precise excavation and backfill volume calculations. So grouped by arrays, because that's how we defined it. For each section, you have starting and ending station, excavation volume according to depth excavation zones, which can be set up by the user. Also, all the upper layer volumes for different types of upper layer. You have excavation volume without upper layer, sand bedding, pipe volume, sand backfill, ground backfill, and surface area. And like I said, everything you have grouped in total for each array. And what is most important, on the bottom, you have it for your whole system, and we see total excavation volume and all of the backfill volumes for the entire system. Okay, that's it about the trenches, and let's now talk a little bit more about the plan stylings. So this is the last function here in the Urbano workspace, and this is basically controlling how your model will look like in plan. Okay, so for now, like I said, default is that the sections are lines and that the nodes are some default blocks. But let's change this. Of course, you can use some of these predefined styles, or you can create your new style. I will call this my plan style. Okay, and I will say for the nodes, I would like to use geometric shapes, and for the sections, I would like to use lines. Okay, and now for these geometric shapes, for each node type, for now we have only plane nodes, you can define graphics for main and plane node. So you can use squares, points, circles, triangles, crosses, everything. I will use circle with blue color and the size 1. For the plane circles graphics, I will use, again, circle, but in magenta color, and the size will be 0.5. Let's click OK. Let's click OK. Now, what the star means for the styles. The style which is set as default, this is the default style. So when you click on draw or conversion of CAD elements or importing from somewhere, the default style will be the one that will be applied. So if I now go on drawing of the elements and start drawing, I will be drawing with this plan style. But if you want to apply it to your system, just double click on it, select everything, apply it, and now we see that the nodes are not the blocks anymore, but this is now plain circles. Also, there is some other options that you can set up. So let's check it. Let's again go to my plan style. Let's edit it. And I don't like that these lines go too deep inside of these circles. So here I will click on line, and I will say draw section, but not to the node axis, but to the outer manhole rim. So now I will not click on OK and then double click on it and apply it. I will click here. update topology entities which are drawn with this style. So when I click OK, everything will be automatically updated. And now you can see that it goes up to the rim of this circle. What else can be done? Okay, let's now switch from the geometric shapes and let's use blocks. But now I will not use some of these blocks that are offered by the software. I will use my own custom block. So you can create your own blocks, but be careful to create in unitless. And I will just take this block, I will copy it, and now I will show you where you can place and store your custom blocks if you would like to use it as nodes. So you go to C, Program Files, Studio Rs, Urbano, which one you will have only one. I have multiple versions here, but this is the version I'm using, 10.2, language of the software that you selected, year of AutoCAD or year of Urbano version for AutoCAD or Civil 3D. And here you have to go to nodes. And here I will just place this block like this. And now when I go here to blocks for the nodes, my block that I called manhole red is appearing here. So you can use also your custom blocks. And of course, you can create different ones for main and plain nodes, but I will use the same one, manhole red. Let's click OK. And also, I will switch for the pipes that I don't like to, I will not use lines anymore, but real pipe contours. And here you can define what to draw. Outer pipe wall, inner pipe wall, axis. You can also additionally hatch something. For example, you can hatch the pipe walls, but I will turn this off. I don't need this. And now I will click update. Let's click OK. And now you will see that it will look completely different. So now, as you can see, this is again blocks, but these are now custom blocks. You can see manhole red. And you can see that you have the real dimensions of the pipes. So you have inner diameter, outer diameter, and also axis of the pipe. If we would like to have also the real styling for the manholes, we can go to that, edit. We can click here to see manhole top view. Again, update, OK. And now we can see the real geometry of the manholes. So here we define circular manholes. Here we define the rectangular manholes. And also here we defined the circular manholes with this angled top. Okay, with this conic structure type. And one last style is the 3D style. Like I said, basically Urbano has its own model. It's up to you if you would like to see it in 2D with AutoCAD blocks and lines, or if you would like to see it in 3D. So if you would like to apply 3D style, again, I could edit my style here, but I will use this already predefined with the software. Double click on it, select everything and apply it. And now everything will be converted from AutoCAD lines and blocks to 3D solid elements. So if we switch to 3D view, we can see that these are now AutoCAD solid elements. But it is important to say that these are not some dead 3D solids. This is still live Urbano model. So this is the manholes, this is the pipes. So if you, for some example, I don't see the benefit, but if you would like to work directly in 3D, of course you can. We can go maybe to function for setting the pipes like this. And of course, the labels remained here in 2D, but doesn't matter. And now I will select, for example, this pipe here. I will use AutoCAD selection, Urbano CAD selection, and I will increase the pipe diameter to 600. Notice how the pipe will update now automatically in 3D. So the 3D style can be used, it is live and it is automatically updating. You can also see here for the label. Let's go back to plan view. You can see also in the label that the label automatically updated to 600 millimeters. Okay, So that is everything for the styling. Let's also now bring back this my plan style, as this is the one that I prefer to use. I always like to see my my pipes and manholes in realistic 2D dimension, and I always prefer it to look it like this and not in 3D solid elements. Okay, and the last thing today, quickly, I will show you how you can create some of your own configurations. Okay, I already showed you how to create your own plan style configuration, but also let's check how you can create your data table. Of course, like I said, it's always good to start from something because all these defaults are really nice. You can just open something, you can edit it, you can change something, but it's also good to know how to create something of your own. So if you want to create a new data table, just click here on new. I will do it for the sections, and I will call it my section data table. Okay. Always in Urbano, when you would like to add some data, you can pick on this icon here. And now this type of dialog opens. You can search for some data, or you can search it here. So when you find the data that you would like to use, for example, starting node name, you can pick on it. You can pick on this arrow and it is appearing here, or you can just double click on it and it will be here. So name, starting node, ending node. If you know how the data is called in Urbano, you can just search for it. For example, length. I will have section length. Also, I would like to also have data about invert. So I will have starting invert elevation, ending invert elevation. I will have slope data. Let's also put some pipe data like pipe nominal diameter and pipe material. This is basically in 99% of the time all the data that I need. So I will say OK. And also you can give this data your custom names. So they will be appearing differently when you open this data table. For example, you can give it a shorter names. I will call this starting node. Here I will say ending node. Here I will say maybe starting invert. Here I will say ending invert. And here I will say slope. But intentionally, I will switch the slope unit from per mile to percent, but I will click here on modify value and I will multiply this with 0.1 to get the slopes in percents. Here I will say nominal diameter. Okay, and I will say that the unit is millimeters, and that's it. You can give it prefixes, suffixes, you can define precision. For example, for the slope, I think 1 decimal place is enough. And for nominal diameters, I don't need this precision, this decimal places. I will keep it as 0. Let's click OK. I will set my section data table to be default like this. And now when I double click on it, here it is, my data table that I created from scratch. Of course, you can also define the width of each column. And once you close this data table, everything will be remembered as well as this column width. So this is also really nice if you always would like for your data table to open like this, for example. And remember, if you change something, for example, this column width, do not close it with X because it will not be saved. Close it with close button. And now when you open it again, this is it. This is the data table. And the very last thing today, we will also create one configuration for the sections, for the section labels, because we see that this type of the label, okay, it can be useful sometimes, but I prefer it to have it differently. So I will go to labels. I will say new section label. I will call this as my section label. And now I will just quickly go through all this data here. So you can define the position of the text. It can be above, it can be below, it can always be horizontal, or it can be by leader, like this. I like it to keep it above. Position, this can be default, which is currently applied. Like I said, if there is enough space, everything will be in one line. If there is not enough space, it will go to 2 lines or with leader. You can always force single row, or you can always go to multiple rows. I like multiple rows. For the label offset, I'll keep 1, but I will decrease this spacing between lines to 0.5. For the slope label format, I will use %. For the delimiter, I will use this sign. And also, you can define some other stuff like this, but also you can add the data. So I don't need the name of the section, but I will have length, okay, in 2D. I will have slope, okay, and I will have diameter. So I will use nominal diameter, and also I will use material. Okay, so that is it. Also, I can define some prefixes. So for the section length, I will say L equals, slope S equals, nominal diameter, I will say DN, and for the suffixes, I will say here in meters, here in %, nominal diameter, I will say in millimeters. For the precision, for the nominal diameter, I will say without decimal places. For the calculated slope, I will say 1 decimal places. Okay, let's now check how this looks like. I will not exit this and apply it to the whole system. I will just take one section, for example, this one here, and I will click on the I button. And now it will show me how this looks like. Okay, I like it, but it can be better. First of all, for this arrow, I will click here, draw direction symbol on the section midpoint. And also I will use some different block for this arrow. You can use some of the predefined blocks, or again, you can put your own. I will use this flow one, okay. And also I would like to put this in just 2 rows, not in 4. So after the section length, I will not go to new line. And after the nominal diameter, I will not go to new line. Okay, let's click on I icon. And this is the label that I prefer to use. Okay, let's click OK. And you see that it will not be automatically applied, but it is here. I will call it as default, and I will apply it again using this option from the ribbon. And now this is applied everywhere. One little change that I will also make. I think the text heights are too big. So let's decrease it to 0.8, because that's the text height for the nodes, like this. Let's click OK, and everything automatically updates. If you notice that these sections, these labels are overlapping one with the other or with the system, of course you can move it. You can move it manually by using this option, Move Label. Just select any part of the label, like this. Select the base point and interactively move the label. So this is the interactive way. Or if you have many places where this happens, and of course it can happen, you can open this function automatic label reposition. You can define which types of the labels you would like to move. I would like to move only nodes. And here you can set up some rules. Maximum number of iterations I will set to 1000. Leader increment I will set to 1. Rotation angle I will set to 45. And the buffer around labels I will say 0.5. What does this mean and how this will work? So the software will first try to rotate the node labels for 45 degrees until there is no more overlapping with the system or with the other label. If this cannot be satisfied, keeping in mind this buffer around the labels, it will increase the leader increment by 1 unit. And it will repeat this procedure until everything is resolved or until maximum number of iterations are reached. And now when I click apply, you see that 16 labels have been automatically moved, and now we don't have overlapping of the labels anymore anywhere in our system. Okay, so with this, we conclude the live presentation.